In this section, we'll be covering two types of memory used in Java. They are called as the stack memory and the heap memory. The primary difference is that in stack memory, it basically stores primitive data types and address to the object. The actual object is stored in heap memory. The other difference is there are no single stack, but Java application, every thread has its own separate runtime stack, whereas there is only one heap space. Now let's take a closer look at stack. So what is stack? If we go with a pure English dictionary meaning, a stack is nothing but a pile of objects that is neatly arranged in order, as depicted in this picture, a stack of book. Now in computer science, a stack is an abstract data type which serves as a collection of elements, and some of the operation that can be performed on stack are push and pop. Push, which adds element to a collection, and pop, which removes an element from the collection. And push and pop work in a principle of LIFO, that is last in first out concept. So for example, in this particular stack, element 3 is the element that was pushed in last, and since it was pushed in last, the element 3 will be popped out first. So Java stack memory is used for execution of thread. They contain method specific value that are short lived. As discussed in previous slide, stack memory is always referenced LIFO or last in first out order. We have here a diagram where every thread has its own runtime stack, and whenever a method is invoked, a new block will be created in the stack memory for the method to hold the primitive values and reference to other object. This block that's shown here is called a stack frame or activation record. So as shown in this diagram, there is a stack frame for main method for thread 1. There is a stack frame from main method and a method which main method calls internally, say a method 1 for thread 2. And as soon as the method execution completes, say method 1 execution completes, the block becomes available for the next method. Also a point to note, stack memory occupies less space compared to heap.